For centuries, questions about the origin of the universe have captivated human thought. What existed before the universe as we know it? If there was no before, what triggered its beginning? These questions have persisted throughout history. Until a few hundred years ago, the prevailing answer involved a divine creator setting everything into motion. Even Isaac Newton believed in a God who created the cosmos. Later, scientists like Albert Einstein thought the universe was eternal, with stars being born and dying, civilizations rising and falling, but the universe itself remaining unchanged on a grand scale. It wasn't until the 20th century, in the 1930s, that compelling evidence of the universe's expansion emerged. By the 1960s, additional discoveries, such as the cosmic microwave background radiation, confirmed that the universe had a beginning, commonly referred to as the Big Bang. This marked a significant paradigm shift, comparable to the acceptance of the heliocentric model centuries earlier. But with this breakthrough came new, challenging questions. What existed before the Big Bang? If the universe had a beginning, does it also have an end? Physicist Brian Cox has recently added to this discourse, suggesting a revolutionary idea. The universe might have existed before the Big Bang. The evolving understanding of the Big Bang. The concept of the Big Bang originated in the 1920s and 1930s when astronomers noticed that distant galaxies appeared to be moving away from us. This observation supported Einstein's general relativity, which indicated that a static universe would be unstable. Everything must either expand or contract. The realization that the universe was expanding suggested that it had once been much smaller, denser, and hotter. As scientists extrapolated this idea back in time, they envisioned a universe so hot and dense that atoms couldn't form, and matter existed in a state of plasma. Further extrapolation revealed a time when particles and antiparticles were created and annihilated due to the extreme energy, and even earlier, a state of quark-gluon plasma. This picture supported the idea of a hot Big Bang as the universe's origin. The discovery of the cosmic microwave background radiation in 1964 further solidified this theory. This faint glow, visible in every direction, is a remnant of the universe's earliest light, cooled to just a few degrees above absolute zero after billions of years of expansion. Beyond the Big Bang. Despite this robust evidence, Cox and other physicists argue that the Big Bang wasn't the true beginning. Instead, it marked the end of an earlier phase called cosmic inflation. During inflation, the universe expanded exponentially in a fraction of a second, smoothing out irregularities and setting the stage for the hot, dense state we associate with the Big Bang. Cosmic inflation doesn't imply a singularity or a state of infinite density. Instead, it suggests that the energy driving the universe's expansion was inherent to the fabric of space itself. The end of this inflationary phase released the energy that became the matter and radiation of the observable universe. But what came before inflation remains an open question. Brian Cox's perspective. Brian Cox has proposed that before the Big Bang, there may have been no universe in the traditional sense. Instead, he describes a state of space-time filled with energy, an almost still, gently undulating sea. This pre-Big Bang state lacks structure, but the energy within it could have caused space-time to expand violently, triggering cosmic inflation. This perspective upends traditional creation narratives and suggests that the Big Bang was not the universe's beginning but rather a phase transition in a larger cosmic story. Cox's ideas echo Stephen Hawking's no-boundary proposal, which posits that space-time is finite but unbounded, much like the surface of a sphere. In this view, the universe has no definitive beginning or end, challenging our linear understanding of time and space. The implications of pre-Big Bang theories. If the Big Bang wasn't the beginning, what does this mean for our understanding of the universe? Several possibilities arise. A pre-Big Bang state. The universe might have existed in a different form before inflation, governed by quantum mechanics rather than classical physics. The transition to the hot, dense state of the Big Bang could represent the moment classical physics took over. Eternal inflation. Some theories suggest that inflation could be eternal, with bubble universes forming within a larger multiverse. In this scenario, our Big Bang would be just one of many such events. Cyclic models. The universe might go through cycles of expansion and contraction, with each Big Bang representing the start of a new cycle. A quantum origin. The universe may have emerged from a quantum fluctuation, with time itself being a product of this process. A continuing mystery. While these theories are fascinating, they remain speculative. The true nature of the universe's origins, if such a concept even applies, is still beyond our grasp. Yet, discoveries like cosmic inflation and the cosmic microwave background have brought us closer to understanding the profound questions of where we come from and what lies beyond. Brian Cox's work, along with that of other physicists, challenges us to think beyond the boundaries of our current knowledge. Whether the Big Bang was the beginning or part of a larger cosmic narrative, the quest to uncover the universe's secrets continues to inspire and expand our understanding of reality. The essence of this narrative revolves around the concept of cosmic expansion and the origins of the universe. Initially, there was an expanse of energy that triggered a rapid growth of space, a phenomenon known as inflation. During this period, ripples or waves formed in this energy field. As inflation ended, this energy converted into matter through the Big Bang, leaving behind patterns of these waves as regions of slightly differing densities in the primordial hydrogen and helium gas. Over time, these denser areas collapsed to form the first stars and galaxies. Eventually, about 9 billion years later in the Milky Way, our Sun was born, accompanied by 8 planets, including Earth. Approximately 13.8 billion years after the universe began, humanity emerged to explore and contemplate its origins. Physicist Brian Cox and others propose that the universe's beginning might not have been a singular event but part of a more extensive, cyclical process. Theoretical physics suggests that understanding the early universe involves reconciling general relativity with high-energy particle physics. However, these theories often break down at the moment of the Big Bang, leaving us with a notion of a singularity, a point of infinite density, which indicates the need for new physics. String theory offers a framework for addressing these challenges, proposing models like the ekpyrotic universe. This theory suggests that the Big Bang was not the universe's beginning but a transformative event in a larger process. Expanding on this idea, the concept of a cyclic cosmology has emerged, where the universe undergoes endless cycles of Big Bangs and Big Crunches, potentially extending infinitely into the past and future. Early versions of the cyclic model face challenges, particularly in aligning with observations of the cosmic microwave background, CMB, the remnant light from the early universe. Adjustments and refinements in the mathematics have since revived the idea, suggesting that the universe might oscillate between expansion and contraction phases. Some proponents believe this has occurred only once, while others envision a perpetually repeating process. Critics of inflation theory, a cornerstone of the Big Bang model, argue it introduces overly complex assumptions. Inflation posits an infinite number of universes, with our observable universe as a single bubble among many, raising questions about what might exist beyond. Conversely, the cyclic model offers an alternative that avoids the need for a multiverse. It hypothesizes that a previous universe existed before our Big Bang, with time running in reverse. This anti-universe concept could explain dark matter as a unique type of neutrino and suggests a mirror universe governed by reversed symmetry and time. This mirrored universe could help explain phenomena like dark matter and cosmic expansion without invoking an inflationary epoch. The theory predicts observable consequences, such as specific neutrino behaviors and the absence of early gravitational waves, which could be tested through future experiments. Ultimately, these ideas challenge traditional cosmological perspectives, suggesting the universe's story is far more complex than we currently understand. While modern science has unveiled much about the universe's history, unanswered questions remain, including the true nature of dark matter and energy and the ultimate origins of existence. The quest to comprehend the universe's beginning stretches the boundaries of human knowledge, reminding us that the story of the cosmos is far from complete.